So hey nerds, this is Suman and this is our today's integral. So in order to do this, we have to make very beautiful substitution. I think we have to substitute 3 times to get the result, right? So how are we going to start this? Just we start by let's put u squared as our tan x, right? And so we get 2u du as secant square x and dx, and 2u du over secant square x becomes our dx, and we get 2u du over, in terms of secant square x we can write tan square x, or simply in more general we can write tan x to the power 2, right? And in terms of tan x we have u squared, so we have to write u squared, and we got this as u to the fourth is our dx. So we got our integral I is integral, in terms of tan x you have to use under root u squared into 2u du over 1 plus u to the power 4. I can written as integral 2u squared du by 1 plus u to the 4th, right? And I can written as integral 1 plus, so I want to separate this, I write u squared plus u squared minus 1 plus 1 du over 1 plus u to the power 4th, right? So now we have to separate this. So I we got is u squared plus 1 plus u squared by 1 plus u to the 4th plus integral we have, so if I take a minus sign common here, I get 1 minus u squared over 1 plus u to the power 4th, right? So now we are going to divide both sides by u squared. So we got I is integral 1 over u squared plus 1 over u squared plus u squared minus integral 1 over u squared minus 1 divided by u squared plus 1 over u squared plus u to the 4th. So if I make this plus, I automatically have to make it 1 minus 1 over u squared, right? So how we can replace these things with another factors? Now we have to replace these conditions into another some satisfying condition, right? So I can write 1 plus, you can see 1 over u plus 1 over u plus u squared is 1 over u squared plus 2u into 1 over u plus u squared. So I can write 1 over u plus u squared minus 2 is 1 over u squared plus u squared. And if there is plus and there is minus, we can replace this by squared plus 2 is 1 over u squared plus u squared. So these two things we have to substitute. So are we going to substitute? In terms of minus we have to substitute this plus, and in terms of plus we have to substitute the minus. So I get integral is, so in terms of here I have 1 plus 1 over u squared divided by, in terms of this I have to substitute this, that is 1 over u plus u squared minus 2 plus integral 1 minus 1 over u squared by 1 plus, in terms of minus we have to substitute the plus, and that is 1 over u minus u squared plus 2. This would be our substitution, right? This would be our one of the key substitution. So here we have to substitute, let's say in terms of plus we have to substitute minus, and that is u minus 1 over u squared plus 2, and here I have to write u plus 1 over u minus 2, and every time here we have du. So if you open this bracket, you will end up getting the same two results. Yes, is integral. I have 1 plus 1 over u squared du, right, and over u minus 1 by u squared plus 2 plus integral 1 minus 1 over u squared du by u plus 1 by u squared minus 2, right. So now, so from here we can actually substitute. So if you see this bracket and if you substitute and if you differentiate, you get this term. Why I had to substitute this? This makes sense because let me do this. Let me substitute this. Put it, z is u minus 1 over u. So what we get? dz is 1 plus 1 over u squared du, right? And if you substitute this as another function w, let us say w is u plus 1 over u, you get dw is 1 minus 1 over u squared du. So our integral is going to look like this. So in terms of this much, look, this is same as this, and you can write it as dz over, and this can be written as z square plus, I can write this as square root of 2 squared plus integral, in terms of this much we can write dw divided by, in terms of u plus 1 by u we can write w squared minus square root of 2 squared. And this is the basic trigonometric identity, that is 1 over under root 2 tan inverse z by under root 2, and this is nothing but 1 over 2 into under root 2 square root of 2 ln w minus square root of 2 by w plus square root of 2 with some constant c, right. So this is going to be 1 over 2 tan inverse, and our z is nothing but u minus 1 over u minus 1 over u upon square root of 2, right, plus 1 over 2 root 2 ln, and in terms of w we have 1 plus u plus 1 over u minus square root of 2 by u plus 1 by 2 plus square root of 2, right. So we basically have u squared is 10x, so we can replace u as square root of 10x. So we get our final result is 1 over 2 tan inverse. In terms of here we have 10x minus 1 over 10x divided by square root of 2, right, plus 1 over 2 root 2, and we have ln, and u we have 10x plus 1 over 10x minus square root of 2 by 10x plus 1 over 10x plus square root of 2 with some constant c, and this is the final integral. And if you want to take LCM, you can do that. So up to there, bye bye.